This problem is asking to find the tension. So this is like a beam, and it's hanging a weight of 150 kilograms. All right, the beam weighs 60 kilograms. We have an angle with the rope, and then the tension. So the question is to find the tension. All right. Where did the pen go? All right, so this is my tension. This is a quick problem. All right, and it's in equilibrium. It's in static equilibrium. That means nothing is moving. All right? So here is the three equations you need to write. You need to write the sum. Some of it may be used, some of it might not. But in general, these are the equations that you need. The sum of the fx equals 0, because nothing is moving. Everything is in equilibrium, is in static equilibrium. All right? Nothing is moving left, right, up and down, or rotational. So we're going to have three equations. We're going to set them equal to 0. The first one is, since nothing is moving left and right, the sum of fx equals 0. The second thing is the sum of fy equals 0. Nothing is moving up and down. And the third one is the rotational one, which means the torques. The sum of the torques equals 0 because nothing is rotating. Nothing is going left and right, and nothing is going up and down, and nothing is rotating. So also we're going to use the torque. The sum of the torque equals 0. There you go. Three equations. Sometimes we use all of them. Sometimes we use only one of them. Okay? But write them down. So, because they're asking for tension, we actually just going to use the sum of the torques equals 0. All right? Because this force here is going to produce this. We have a 90-degree angle. Remember, the tension, the force, has to be perpendicular to the distance that is coming from the pivot. So we are choosing the point of rotation as the pivot right here. So we're choosing this point as the pivot, which means we're going to rotate across this point. You have a choice. You can choose this one as the pivot, but if we choose this one, the T is not going to be involved, because if you choose a pivot here, the T does not produce any torque. So you're not going to get it involved in the equation, so you're not going to be able to solve it. All right? That's why we're choosing this one as the pivot. All right? So let's do the sum of the torques equals 0. So the first one is let's put the gravity, the weight of the beam is 9.8 times the mass of the weight, which is 60 kilograms. All right, and that's gonna give you 588 newtons. All right, good. All right, 158. The weight is going to be 9.8 times 150. And that's going to be 1470 Newton. Right? Now, we have the force, the weight of the beam. We have the force, the weight of the box that we have here. And then we have a tension. These are all the forces we need. The forces here are not going to cause any torque because the radius is 0. The distance from the pivot to the force is 0, so it's not going to have any torque. The torque is going to come from this weight, this force here, the weight of the beam, and the tension. So let's write the forces. Let's write the torques. Let me erase this. All right. So we have 588 is perpendicular to to the distance to the pivot. So it's just going to be 5, because let's do this. Let's call this positive. Let's call this positive torque, and let's call this negative torque. You understand? This is clockwise, and this is counterclockwise. So this is our convention. You got to choose your convention. It's okay if you choose the opposite. The answer at the end is the same. All right? So we're going to choose convention, clockwise positive, counterclockwise negative. Clockwise positive, counterclockwise negative. Counterclockwise negative. All right. So 588. Is it going clockwise or counterclockwise?
Clockwise.
Clockwise. So you're going to multiply 588. Pay attention. This is easy. 588 times the distance from the center to the end, which is 2, because the whole thing is 4 meters. So you're going to write 588 times 2. And we say that's going to be that the clockwise is positive. That's why we're not putting negative, because we're saying that clockwise is positive. Now the other one, plus, because it's also clockwise, 1470 multiplied by what?
2. Or no, 4.
Times 4, because it has the whole distance. From here to here is 4 meters. 4 meters from here to here. So this one is a half, so you only go on times 2, but this one is times 4. All right, we have one more torque that's going to come from tension. Now tension, is it going to be clockwise or counterclockwise? Just look where it's pointing. If it's pointing this one, that means it's going to go, it's counterclockwise. The tension is counterclockwise, because it's going like this way. Right? So it's going to be minus. This is where the trick is, like some students got messed up. All right? You need to know if you set your convention as clockwise positive, and these two forces are positive, they're going to cause a positive torque, but this one, all right, it's going to be the counterclockwise, so it's going to be negative. So it's minus T, right? Now, what is the distance from the line of action of T, of the tension, to the pivot?
2 meters.
No, this is the line of action. This is T, this is the line of action, right? Now, the line of action going to the perpendicular to the pivot, that is the distance right here. This. All right? So how much is that distance? If we have the hypotenuse is 4, and this is a 90-degree angle, and we have the T. All right? Because some of you might still having problems with trigonometry. All right? So let me put it aside. So this is the triangle, this and that one, right? So we have a right triangle.
4 times 10 to 40.
So this is 90 degree. That's 40 degree. This is 40 degree. We're trying to find this D, and this is the T. All right. Now, this is the T, this is the D, and we have the 4 as the hypotenuse. So we have 4. Now, which function that relates 4 and T? All right. Now we're gonna have, if you write sine, because we're trying to find D. If you write sine of 40, now this is trigonometry, the basic trick. We have angle 40, we have 4 meters is the hypotenuse, and we have D that we're looking for. All right, so we're gonna write sine 40 equals to opposite. Remember, sine is opposite over hypotenuse, so it's going to be D over 4. All right, so if you cross multiply, you're gonna get D equals 4 sine 40. So D is 4 sine 40, right? All right, so we're gonna bring that 4 sine 40, and then we're gonna multiply it by T, because you're trying to find the force times D, which is the perpendicular distance to the pivot. So D is 4 sine 40. So you're gonna write T times 4 sine 40. And then you make that equal to 0, because those are the only torques we have. All right, so this is the equation, and then it's one equation, one variable, one unknown, T. And we can solve for T. All right? Now it's just the algebra. We already done the physics. All right, you need to know that you always pick the distance that's perpendicular to the line of action, D, and that's 4 sine 40. It's like a basic trick. 4 sine 40 is D if we have hypotenuse and we have the angle. All right, if you relate hypotenuse and opposite is sine. So if you work with this equation, okay, which is just basic equation, you're gonna get T equals to 2,745.5. So I'm not gonna go into details into solving that equation, okay? It's one equation, one variable. You should be able to solve it. Just change sine 40 from the calculator, and then you solve the equation. So you're gonna get 2,745.5. 2,745.5 newtons. And that's it for this video.